Let me show you something that looks illegal. Let's run this. You can see it gives a 4 at the end. That extra 4 at the end looks wrong. We learned since childhood that zero point 0.1 plus zero point 0.2 always gives zero point 0.3. So, what is the problem here? Is this a bug in Python? No. What you are about to see will permanently change how you think about numbers in programming. Now, let's see why this happens. We humans use base 10, which essentially stands for the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We use these digits to represent every number. But computers use base 2, which is binary, which means they use zeros and ones to represent everything. For example, if you had to say 2 in binary, it will be 1 0, and for 3, it will be 11, which is 1 and 1. That means computers store numbers using only zeros and ones. Now, here's the problem. Some decimal numbers that look simple to us cannot be written exactly in binary. For example, 1 divided by 3 in decimal becomes 0.3333, which continues still forever. It never ends. Binary has the same issue, but with numbers like zero point 0.1. Now let's see what zero point 0.1 really looks like. In binary, zero point 0.1 becomes an infinite repeating fraction, something like this. It never ends. But computers do not have infinite memory, so they cut it off, which means the stored value is not exactly zero point 0.1. It is the closest approximation. Python normally hides this tiny accuracy. Now, watch this. If I ask Python to just print the value of zero point 0.1 and the value of zero point 0.2, it will just give me zero point 0.1 and zero point 0.2, which is because Python hides the tiny inaccuracies. They look clean. Now, let's force Python to reveal the full precision. Now, this code, what it does is it tells us the value of zero point 0.2 till 20 decimal places. So let's try running this. You can see that zero point 0.1 gives us a 5s at the end, and zero point 0.2 gives us this 11 one triple ones at the end. So these are not exactly zero point 0.1 and zero point 0.2. They are slightly larger. Now let's add them up. You can see up until 20 decimal places, it has 4, 4, 4, and 1, which is not equals to zero point 0.3. That tiny floating point error appears because we added two approximations. This isn't just Python. It's not a JavaScript bug. It's not a C++ bug. It's how floating point numbers work under the IEEE 754 standard. Almost every programming language does this. The math is not wrong. The representation is limited. Now let's see how you can handle this. If you just want a cleaner output, you can just round this up. So if you want to round this, use the round function, add zero point 0.1 and zero point 0.2, And let's say we wanna round it till 1 digits. So it's gonna give us just 0.3. But if you need exact precision, like in finance, use the decimal module. We are gonna import the decimal function from decimal module and let's represent the numbers. We are gonna store 0.1 into the variable A and we are gonna store 0.2 into the variable B. Now, let's print the values. Let's run the code and see the output. As you can see, it gives us the correct value, which is 0.3. This avoids binary floating point approximation. So, the next time you see 300000000000004 at the end, do not panic. You just witnessed how computers actually understand numbers. If this made you look at programming differently, subscribe for more deep but simple coding explanations. And don't forget to comment wow if this just changed how you think about math in computers. See you in the next one.